హాయ్ గైస్, వెల్కమ్ బ్యాక్. ఈ లెక్చర్లో మనం ప్రీవియస్ ఇయర్ క్వశ్చన్స్ డిస్కస్ చేస్తాం కదా. ఆ ప్రీవియస్ ఇయర్ డిస్కషన్ పార్ట్లో network analysis. So we'll try to learn network analysis with the help of some amazing numericals, okay, and which are different to the previous year questions also. Okay, let me quickly take you to the questions. ఒకసారి చూద్దాం ఏమేమి క్వశ్చన్స్ చూస్తున్నాం మనం. Yeah, these are the questions what we're going to see in this. Okay, చూడండి ఈ క్వశ్చన్స్ కొంచెం ఇంట్రెస్టింగ్గా కూడా ఉన్నాయి. జెన్కోలో అడిగిన క్వశ్చన్ అది. ఓకే, అండ్ రియల్ ఇంట్రెస్టింగ్ క్వశ్చన్స్ ఆర్ దేర్. సో దిస్ నెట్వర్క్ అబౌట్ స్టార్ మెష్ థీరం, మీకు స్టార్ డెల్టా థీరం తెలుసు, స్టార్ మెష్ థీరం ఏంటి చూద్దాం ఇవన్నీ. ఓకే, సో ఇందులో కరెంట్ ఫైండ్ అవుట్ చేయడానికి దీంట్లో ఈ షార్ట్ సర్క్యూటెడ్ దాంట్లో కరెంట్ ఎంత, చాలామంది ఇక్కడ ట్రాప్ అవుతారు. Yeah, how to solve this current, how to find this current, and some real interesting questions are there. Okay, so I hope you will have an active participation from your end. We're expecting some nice participation. Okay, so మీరు చేయవలసిందల్లా ఆప్షన్ ఏదైతే మీకు టైమర్ రన్ అవుతుంటుంది కింద, ఆ టైమర్ ప్రకారం కింద మీరు ఆప్షన్ ఏదైతే అది మార్క్ చేయాల్సి వస్తుంది. ఓకే, సో లెట్స్ గెట్ టు ద ఫస్ట్ క్వశ్చన్. I hope you're ready. Bang. This is the first question. Try this. We're getting some answers. You just mark your answer, that's it. A, B, C, whatever it is, you just put it up there. Guys, read the question carefully once, what is given here. Question, you have to read it carefully. Hi Viraya. That's good. So only few people have answered it. Okay, so I don't know what the others, how come you're answering wrong. Okay, only few people have answered it. Let's see how to handle such kind of questions. This is an easy question. Okay, this is definitely an easy question, but yet you missed it, means there is something to worry. Okay, so Kranti Kumar has made it correctly. Okay, let me just explain it. Explain chestanu. The charge of an electron is known to be this much. So electron is having how much charge? One electron is equal to 1.6 into 10 power minus 19 coulombs. Okay, this much coulomb charge one electron is having, that's what it says. In a circuit, the current flowing is 1 ampere. The current flowing is 1 ampere. So how many electrons will be flowing through the circuit? It is saying, it's not asking how much is a coulombs. If one electron is flowing, how much is the coulomb? That is not the question it is asked. It is asked, if current flowing is 1 ampere, means what is this means? This means 1 ampere current is flowing means 1 coulomb charge is passing in 1 second. That's what meant by 1 ampere current. 1 ampere current means 1 coulomb charge is passing in 1 second. So if one electron is having this much coulombs, tell me 1 coulomb means how many electrons? How many electrons? Simply just cross multiplication or inverse it. So the number of electrons is equal to 1 by 1.6 into 10 power minus 19. So 1 coulomb means this much number of electrons. Just cross multiplication. Take it as x. So x value will come out to be this. Okay. So question, they will also ask a question. This is ISRO question. Okay, ISRO previous year questions. Such an easy one. They will also directly ask this question: what is the charge of one electron? When one electron is having how many coulombs? They will ask even that. Okay, so try to be careful, guys. Simple questions. I don't know. You're missing. Okay, you should not. Anyways, so this much is the number of electrons. 1 coulomb means this much number of electrons are passing in 1 second because 1 ampere current is set. Okay, so 1 by 1.6 in 10 power minus 9, this will result to be something into 10 power plus 19 for sure. So this is wrong because they are having minus plus 19, this is having, okay, plus 19, this is having minus 19, this is wrong. So this is having plus 12, this is wrong. If you take 1 by 1.6, you will never get 1.6, right? So this is also wrong. So you're not using your calculator yet, you're able to say yes, this is answer. You don't have to do the math. 1 by 1.6 how much? Of course, if you remember this is good. 1 by 1.6 is 0.625. Means 1 coulomb charge means that much number of electrons, that many huge number of electrons are passing in just 1 second. Okay, so answer is C. So it goes to Kranti Kumar. Superb, good job. This is for you. Anyways, let's go to the next question. Okay. Timer is running. 25 seconds left. Okay, time's up. Viraya, you can just say A. Viraya, you can just say A so that our AI will detect your answer. మీరు ఆప్షన్ ఏ అని పెట్టవలసిన లేదు. ఆప్షన్ ఏ అని పెడితే రాదర్ ఇట్ మే నాట్ పిక్ ఇట్ అప్ ఆల్సో. ఆల్రెడీ ఇది జస్ట్ చూసాం కేపీటీసీఎల్లో అడిగిన క్వశ్చన్ ఇందాక చెప్పాను నేను. డైరెక్ట్గా క్వశ్చన్ అడిగేస్తున్నారు. వాట్ ఈస్ ద ఎలక్ట్రికల్ చార్జ్ ఆఫ్ వన్ ప్రోటాన్? How much is electrical charge? Electron is negatively charged, proton is positively charged. Mass lo difference untadi, but charge lo same untadi. No difference in the charge. Okay, so just like the previous one, it is 1.6 into 10 power minus 19 coulombs positive. Proton is a positive charge. So answer is A. చూసారా, కేపీటీసీఎల్ అడిగింది, కర్ణాటక పవర్ ట్రాన్స్మిషన్లో అడిగిన క్వశ్చన్ అది. ఓకే, ఈజీ వన్. యా, లెట్స్ సీ హౌ మెనీ ఆఫ్ యు గోనా ఆన్సర్ దిస్ ప్రాపర్లీ. ఇది ఎంతమంది ప్రాపర్గా ఆన్సర్ చేస్తారు చూద్దాం. Wow. Viray has answered correctly. I think he marked. Good. Keep it up. Others, మీకు కొన్ని ఇంట్రెస్టింగ్ అప్డేట్స్ మీరు కనెక్షన్లో ఉండాలంటే కనుక కింద ఒక వాట్సాప్ ఛానల్ లింక్ ఉంది. ఓకే, డిస్క్రిప్షన్లో వాట్సాప్ ఛానల్ లింక్ ఉంది. జస్ట్ ఫాలో దట్ వాట్సాప్ ఛానల్. ఓకే, PiSquare వాట్సాప్ ఛానల్. So you're going to get some interesting updates. Okay, don't miss that. Shortly you're going to see core job openings. We are tying up with different companies. Okay, so we'll be training you people. మేము మిమ్మల్ని ట్రైన్ చేస్తాం. ట్రైన్ చేసిన తర్వాత మీకు జాబ్ ఓపెనింగ్ కూడా will for the qualified people, we're going to give you the job opening as well. Okay, job kuda meme almost 4 lakhs package unna vaatiki will be offering it. Okay, so stay tuned for that. Dan details anni meeku channel lo updates vastha untayi. Okay, it's not for everyone, it's only for PiSquare users. Okay, so I think you can see pin chesi undi already chat. You can check. You can join the WhatsApp channel. You can follow the WhatsApp channel. Okay. Yeah. In house wiring, the total connected load per sub circuit. Now, first of all, domestic wiring lo, the TSGENCO question adi. Domestic wiring lo sub circuit ante me intlo domestic wiring ante me intlo sub circuit ante enti first. అది అర్థం చేసుకోవడానికి ట్రై చేయండి. ఓకే, ఇది ప్రతి ఒక్కరు క్వశ్చన్ కోసం కాదు, మీరు తెలుసుకోవడం కోసం చూడాలి. ఓకే, ఫోకస్ పెట్టాలి. బికాస్ మీ ఇంట్లో సబ్ సర్క్యూట్ అంటే ఏంటి? సబ్ సర్క్యూట్ అంటే సపోజ్ మీ ఒక టూ బిహెచ్కే అనుకుందాం. 2 bedroom 1 hall 1 kitchen. ఒక బెడ్రూమ్లో ఫ్యాన్స్, లైట్స్ ఆర్ టీవీ, చిన్న చిన్న ఇలా అప్లయన్స్ ఉంటాయి కదా, ఏసీ ఇలాంటివి కాకుండా ఇవన్నిటి కలిపి ఒక స్విచ్ బోర్డ్ ఉంటుంది కదా, ఆర్ మేబీ 2 స్విచ్ బోర్డులు ఉంటాయి కదా. ఆ 2 స్విచ్ బోర్డులు కలిపి ఆర్ మేబీ ఒక రూమ్లో ఉన్న స్విచ్ బోర్డులు అన్నీ కలిపి ఓకే ఒక ఎంసీబీకి కనెక్షన్ ఇవ్వాలి మనం, ఆర్ ఒక ఫ్యూజ్ నుంచి తీసుకోవాలన్నమాట. సో దాన్ని ఒక సబ్ సర్క్యూట్ అంటారు. ఇప్పుడు ఎంసీబీలు వాడుతున్నారు కదా, ఫ్యూజ్, నోబడీ యూజింగ్ ద ఫ్యూజెస్, ఎవ్రీబడి యూజింగ్ ఎంసీబీస్ ఎట్ ఎ హోమ్. సో అంటే ఒక ఎంసీబీ నుంచి ఎంత లోడ్ కనెక్ట్ చేయొచ్చు, దట్స్ వాట్ అ సబ్ సర్క్యూట్ మీన్స్. ఓకే, హౌ మచ్ ఇస్ ద లోడ్ విచ్ యూఆర్ కనెక్టింగ్ ఫర్ వన్ సబ్ సర్క్యూట్ అకార్డింగ్ టు ఇండియన్ స్టాండర్డ్ రూల్స్, ఐఈ రూల్స్, ఇండియన్ ఎలక్ట్రిసిటీ రూల్స్. ఫర్ నార్మల్ సబ్ సర్క్యూట్ 800 watts అంటే ఈ ఫ్యాన్స్, లైట్స్ ఏవన్నీ కనెక్ట్ చేస్తున్నారు ఇవన్నీ కలిపి 800 watts కన్నా తక్కువ ఉండాలి. దాన్ని ఒక ఎంసీబీకి ఇవ్వాలి. సపోజ్ 800 watts కన్నా ఎక్కువ వస్తుందంటే కనుక యూ హ్యావ్ టు టేక్ అనదర్ ఎంసీబీ, యూ హ్యావ్ టు టేక్ ద పవర్ సప్లై ఫ్రమ్ ద అనదర్ ఎంసీబీ. అంటే ఏంటి, ఒక సబ్ సర్క్యూట్లో ఏమన్నా ఫాల్ట్ ఉంటే కనుక ఓన్లీ ఆ కరస్పాండింగ్ ఎంసీబీ ట్రిప్ అయిపోతుంది, రిమైనింగ్ థింగ్స్ విల్ వర్క్ యాజ్ ఇట్ ఈస్. సో ఫర్ దాట్ limit is how much? 800 watts is a limit beyond which you cannot connect to one MCB. Okay, this is a rule. You have to understand such things. Okay, this is a normal sub circuit. And ఆ ఒక సబ్ సర్క్యూట్ నుంచి మీరు ఎన్ని కనెక్షన్ తీసుకోవచ్చు? 800 watts అంటే నేను బల్బులు తీసుకుంటున్నాను సార్, నాట్ జస్ట్ 800. పవర్ లెవెల్లో చూస్తే 800. అదే ఎన్ని ఎక్విప్మెంట్స్ కనెక్ట్ అయి ఉండాలి సార్ అంటే you cannot exceed more than 10 equipment. అంటే లైట్స్, ఫ్యాన్స్ అన్నీ కలిపి 10 కన్నా ఎక్కువ ఉండకూడదు మళ్ళీ. ఓకే, సో సపోజ్ ప్రతిదీ 50 watts అనుకుందాం. ప్రతి అప్లయన్స్ వాట్ యూర్ యూజింగ్ ఇది 50 watts. సో 80 కావాలంటే ఏంటి, 50 watts అంటే సార్ నేను ఆల్మోస్ట్ 14, 15, అలా 16 పెడతాను నేను. నో, యూ కెనాట్ డూ దాట్. ఓకే, 10 equipments only can connect it. Each one is 50, it turns out to be 500. This is what one part. Or what is wise, 800 watts you cannot exceed, or 10 equipment you cannot exceed. If it is a power sub circuit, ఏంటి పవర్ సబ్ సర్క్యూట్ అయితే అంటే ఏంటి మీ గేజర్స్ కానీ ఎయిర్ కండిషనర్స్ కానీ వీటికి how much is what do you think, how much is the capacity? If it is normal sub circuit, it is 800 watts. If it is a power sub circuit, then how much? Tell me. Yeah, I'm waiting for answer. If it is a power, how much? Give it a shot. Nobody? Oh, come on. For power sub circuit, at least give it a try. ఏదో ట్రై చేయండి, చూద్దాం ఎంతవరకు వస్తుందో. Very good. Vinod, you're amazing. It's 3000 watt. If it is a power sub circuit, it is a 3000 watt. Okay. And how many equipment you can connect? How many equipment you can connect for the power circuit? Yes. Try some number. It's okay if it is wrong. If it is a power sub circuit, 3 kilowatts for one power sub circuit. How many equipments you can connect? How many plug points or how many equipment you can connect there? Very good, Vinod. Very good, Aditya Mohan. You're amazing. It's 2. Okay, you can connect ఇవన్నీ ఈ డీటెయిల్స్ అన్నీ ఎలా తెలుస్తున్నాయి సార్ అంటే ప్రీవియస్ ఇయర్ క్వశ్చన్స్ని ప్రాక్టీస్ చేస్తూ ఉంటే ఆల్రెడీ PiSquare యాప్లో ఉన్నాయి మీకు అన్నీ, చాలా ఫ్రీగా కూడా చాలా ఉన్నాయి. ఓకే, ప్రాక్టీస్ టెస్ట్లో అనవ్వండి, యూ హ్యావ్ ద ఫ్రీ ప్రాక్టీసెస్ ఆల్సో అండ్ యూ ఆర్ నాట్ యూటిలైజింగ్ ఇట్. వాట్ కెన్ బి డన్? ఓకే, ఈజ్ దర్ ఎనీ లాజిక్ ఇన్ దిస్? ఇట్స్ అ రూల్ డియర్. ఇది ఎందుకు మనం సెపరేట్ చేయడం ఎందుకు? వై వీఆర్ సెపరేటింగ్ ఇట్? వీఆర్ సెపరేటింగ్ ఇట్ బికాస్ ఇఫ్ దెర్ ఇస్ అ ఫాల్ట్ విత్ ఇన్ దట్ జోన్ ఉన్నప్పుడు మనకేంటి ఫాల్ట్, ఆ ఫాల్టీ సెక్షన్ మాత్రమే ఐసోలేట్ చేయాలి, హెల్దీ సెక్షన్ని మనం నార్మల్గా ఉంచవచ్చు. ఓకే, సో ఒక టిపికల్ వాళ్ళు రూల్ సెట్ చేసేటప్పుడు ఎలా చేస్తారు, ఒక టిపికల్ రూమ్లో ఒక్కొక్క రూమ్కి ఒక్కొక్క సబ్ సర్క్యూట్ పెట్టాలా, అది వాళ్ళ మైండ్. అలా చెప్పకుండా లోడ్ వైజ్ అనమాట. అంటే ఒక రూమ్లో ఏ ఉంటాయి జనరల్గా ఆ పాయింట్స్ అన్ని పెట్టుకుని దే డిజైన్డ్, దే ఫ్రేమ్డ్ ఎ రూల్ 800 వాట్స్ కన్నా ఎక్కువ ఉండకూడదు. దెర్ సెట్ ఎ రూల్. ఓకే, ఇట్స్ ఐ రూల్, ఇండియన్ ఎలక్ట్రిసిటీ రూల్. Anyways, I think this point is clear. You must have learned something. Yes or no? Good. So let's go to the next question without further ado. Are you guys ready? Are you guys ready for the next question? Bang. Here you go. Oh, I didn't move here. This simple one, I think you'll be able to do this. How crazy. No answer. Time's up. No answer. That's really bad. Okay. I didn't get any answer. Not even one person has answered for this. It's a previous year question, but yeah. It's for Karnataka power transmission. Okay. Anyways, let me explain this. Focus here. Your time is up. So now you have to focus here. What is the charge on each capacitor when a 150 volt is applied across two capacitor values 5 microfarad and 10 microfarad connected in series. They are connected in series. Now you're applying a voltage of 150 volts. So now in a series connection, the charge is same charge, whatever in this, here also it will have the same charge. Okay. So now it is asking for what is the charge on each capacitor. Okay. So let's see what's the equivalent capacitance first, because the total voltage is this. So what's the equivalent capacitance? Or else you can apply voltage division. You find out this voltage, it's farad. You can find out the Q value from the formula. The formula, charge stored in the capacitor is proportional to the voltage applied to that capacitor, and the proportionality constant is Q is equal to CV. Okay, there's a formula. Now the total voltage is known to us, which is total voltage how much? 150 volts. Now your objective is to find out what's the total capacitance. For finding out total capacitance, they're in series. Just tell me in the simplest way. I gave you an amazing tip in the course. I gave an amazing tip. Using that tip, you tell me what is the equivalent capacitance of this when they're in series. 5 plus 10, 15. Can I say equivalent capacitance is 15 microfarad? Can I say that? Yeah? Good. We got some answers. It is not 15. You cannot add them up. When capacitors are in farad, don't think that, hello you, careful. Capacitor series, it does not mean 1 by C1 plus 1 by C2. If their values are in farad, then reverse formula you have to apply. If the values are in ohmic value, you will still add them up just the way you're doing resistor case. You should not see whether it is a capacitor or inductor. You should see whether it is a farad or ohm or a Henry. That's a key point. Understood? If you understood, give that thumbs up. If you understood, give that thumbs up. Yes? In the chat. Understood? Good. Now they're in series. So resultant is R2R method. R2R method. Highest value is 10. Keep that 10 microfarad by it is 2 times 2 plus 1, 3. 10 by 3 is 3.33 microfarad is a C equivalent. You don't have to do C1, C2 by C1 plus C2. All these things are not required, because you're not writing a descriptive exam. Rather, you're writing competitive exam. Time is a matter. So these kind of little tips are going to save huge time. They are going to save huge time. You should be ready to grab those changes. So what I did not use C1, C2 by C1 plus C2. I just use a tip. Okay. What is the tip? 10 microfarad is the highest. Highest by how many times more? It is 2 times more. 2 plus 1, 3. 10 by 3, which is 3.33 microfarad. That's it. Anyways. So now the C equivalent is known, 3.33 microfarad. 3.33 microfarad into 150 microfarad. That will definitely is not this. You will not get 0.5 coulombs of charge, because it's in microfarad. So 3.33, or I'll simply multiply this with 150. That's it. You don't have to even simplify this. 3 here 50 times. So 50 into 100, 500 microcoulomb is answer. See? You're thinking that I'll have to use a calculator and all, but you have to use your aptitude skills. If you use that, you will directly get the answer in a short go. Okay. So these tips are very important. You have to focus on those tips. Are you guys okay? Shall we go to the next question? Okay, done then. Bring it on. Let's bring it on. Next one is on the screens. This is, I think you're unable to see this. This is ISRO question. ISRO electrical question is this. Okay, time's up. Time's up, time's up. So we got just few answers, rather two answers. Viray is saying C and Vamshi is saying A. Let's see who is right. Let's see who is right. Okay guys, thank you for your love. Thank you for your love. And that's what I'm saying. You are going to get huge benefit being a PiSquare follower. You just go to PiSquare WhatsApp channel, which is pinned in the chat. Follow that channel. You are going to get amazing benefit, job opportunity you're going to get. Okay. Anyways, we're planning for that. We're tying up with different institutes, different organizations, as in different companies, so that we'll be placing you there. Okay, that will be our responsibility. Anyways, let's come to this question. Just what you have to do is just follow the WhatsApp channel. We'll be updating there. Okay. In the network shown in the figure below, the current in the 12 ohm resistor is 5 ampere. So it is given already, everything is given. The description, whatever is the description, it is given in the figure as well. The battery voltage is how much? So we got answers A, D, C, whatever. So to find out this voltage, I think we'll have to use simply the KVL, KCL, that's it. Nothing else. So what is this voltage? This voltage is how much? 12 into 5, which is 60 volts. 60 volts is a voltage here. I'm just multiplying these two. Now 60 volts is there, so what is the current in this? 60 volt is there, current in this is 60 by 4. It is 60 by 4 is 1 and 20, 15 ampere. 60 by 4 is 15 amperes is the current flowing in this. Now what's the current flowing in this? 20 ampere is the current flowing in this by applying KCL. 15 plus 5, 20 amperes. So what is the voltage here? 6 into 20, which is 120 volts. This voltage is 120. This voltage is 60. Total voltage is how much? 180 volts. If this voltage is 180 volts, this voltage is also 180 volts. So this current is 10 amperes. Because 180 volts by 18, 10 amperes. This is 10 ampere, this is 20 ampere, this current is 30 ampere. But the question is asked for what is the value of E. So E value will be definitely greater than 180. So this is wrong, this is wrong. So either of these two is right. What is right? 30 into 40, the voltage across this is 120 volts. 30 into 40, 120 plus 180, applying KVL here, 120 plus 180, which is 300, is answer. You are thinking that it is a lengthy or big question and all, but you can pretty easily solve this question well within 30 seconds if you have all of these concepts handy. Okay, you should be on the fly, you should be calculating all of these. Okay, means guys, remember this point. మీకు గనక KVL, KCL పర్ఫెక్ట్గా వస్తే నెట్వర్క్స్ అలా అయిపోద్ది. దరిద్రం ఏంటంటే మీకు KVL, KCL వచ్చు అని అనుకుంటారు, మీకు రాదాయే. ఎస్. సో KVL, KCLకి ఫ్రీగా వీడియోస్ ఉన్నాయి PiSquare యాప్లో. ఓకే, PiSquare యాప్లో ఫ్రీగా వీడియోస్ ఉన్నాయి. KVL, KCL బేసిక్ ఫండమెంటల్ కాన్సెప్ట్స్ అవి కనుక మీరు ప్రాపర్గా తెలిస్తే, రెసిస్టెన్స్ సిరీస్లో ఉందా, షంట్లో ఉందా, ఈ బేసిక్స్ కనుక క్లియర్గా తెలిస్తే యు విల్ రాక్ నెట్వర్క్ అనాలిసిస్. ఇది తెలియక స్టార్టింగ్లోనే మీరు ఫౌండేషనే వీక్గా ఉండి తర్వాత మీరు ఎన్ని బిల్డింగ్లు కడదామని ట్రై చేసినా టప్ పడిపోతాయి కిందకి. ఓకే, there is no use of doing all those things if foundation is weak. You know, hardly 10 hours it's going to take. అంటే ఈ రోజు డిసైడ్ అయితే రేపు ఈ టైం కల్లా మీరు మాస్టర్ అయిపోవచ్చు నెట్వర్క్ అనాలిసిస్లో. కానీ మీరు చెయ్యరు. బద్ధకం నాకు తెలియదా ఏంది. నెక్స్ట్ క్వశ్చన్, ట్రై ఇట్ అవుట్. నెక్స్ట్ క్వశ్చన్, ట్రై ఇట్ అవుట్. Wow, Jay Shriram is rocking. Good guys. Amazing response. Amazing and quick response. Madhavi good. Shravan good. Chandu good. Viraya has been good. Good guys. Keep it up. Keep it up. Quick at correct responses. That's much appreciated. Okay, your time's up. Let me just handle this. The electric heater draws 10 amperes of current from 230 volts line. The resistance of the heater is... Resistance of the heater? Have it? GENCO question. Such an easy one. Applying Ohm's law, you're absolutely right. Applying Ohm's law, voltage is given, current it is drawing is given. So simply I is equal to V by R, or it is asked for R is equal to V by I, 230 by 10, answer is 23 ohms. Okay, very good. That's the previous question, what to do. Tell me, what is the power consumed by this heater? How much power this heater is consuming? This is also a simple question. I want you to type the answer. I want you to type the answer. This is AE questions, Chandu. This is AE question. PiSquare AE question. Is it? Yeah, it is AE question. Yes. Power is simply 2300 watt. So if it is asked for power, this much watt would have been the answer. Okay. So moving on to the question, simply voltage into current. That's it. That's a power. Okay. Next one. Yeah. Let's see how many of you are going to answer this one properly. Here, rather than the answer, point is important. The conclusions, the observations, the concept behind this is very important. I think most of you don't know the concept behind this. You may give the answer, but the concept, I think you may miss it. You're going to learn that. If you learn it, it's great. I'm sure this is not known to most of the people. I'll give you that. I'll give you that. Wow. Viraya is a rock star. He is rocking. Okay. Good, Viraya. Anyways, your time is up. So I'm explaining it carefully, guys. Everyone stop typing. Pay attention. The circuit shown above and below. The circuit shown below can be easily solved by దీన్ని ఈజీగా సాల్వ్ చేయడానికి ఏ మెథడ్ యూజ్ చేయాలి? Can I use series parallel method? No, these two are neither in series nor in parallel. ఇంకొక వరస్ట్ పార్ట్ ఏంటంటే చాలామంది స్టూడెంట్స్కి సిరీస్ ప్యారలల్ కూడా తెలియదు బాయ్. ఏం చేస్తాం, అట్లా ఉంటుంది మనతో అని. సో వాళ్ళ కోసం డౌన్లోడ్ చేయండి, యాప్లో ఫ్రీగా వీడియోస్ ఉన్నాయి. సిరీస్ ప్యారలల్ ఏంటి, బేసిక్స్ గురించి అన్నీ ఫ్రీగా ఉండవు. ఓకే, కొన్ని వీడియోస్ ఫ్రీగా ఉన్నాయి. ఫ్రీ వీడియోస్ చూస్తే మీకు చాలా క్లారిటీ వస్తుంది డిఫరెంట్గా. యూ గెట్ అ లాట్ ఆఫ్ క్లారిటీ ఆన్ దిస్ సిరీస్ ప్యారలల్. ఓకే, వెదర్ దేర్ ఇన్ సిరీస్ ఆర్ షంట్, ఆల్ దీస్ థింగ్స్ విల్ బి ప్రెటీ మచ్ డామ్ క్లియర్. So you cannot apply series parallel to this. So how to solve it? To solve this, you'll have to use star delta transformation. See, look at this. They are in star, you can connect them in delta. Or else they're not exactly in star also, because these 2 points seems to be different, but they are pretty much same. So this one and this one, these two are in parallel, that's true. This one and this one, they're in parallel, that's true. Because when you're joining these two, they are same essentially, because node, if you see, it is C only. It is just C only. Okay. And to further solve it, you have to use a star delta transformation. Now, interesting point of this question is, nowhere it is mentioned star delta transformation. It is said star mesh theorem. In generally, the generalized transformation is star mesh transformation is a generalized transformation. Means you can convert, this is also a star, buddy. This is also a star. This is also a star. Don't think that you have 3 resistors are meeting at one point, that is star. This is also a star. 5 resistances meeting at one point, this is also a star. Okay. So if it is a 3 resistances and converting them into 3 resistance delta, that is called a star delta transformation. Suppose you have now 5 resistance star, now you are converting into the other form, it is a mesh. In general, it is a star mesh or star polygon transformation. Star polygon transformation. Now, here the formula is, suppose if, careful guys, if 5 resistances are there, how many resistances will be there in the corresponding mesh, tell me? If 3 resistances are there in the star, 3 resistances you will get in delta. I am asking question, if 5 resistances of star are there, how many resistances in the delta, in the mesh? Tell me. You cannot call it as delta, you will call it as mesh. How many resistances in the mesh? It is regarding, suppose if this star has n resistances, if this star has n resistances, the corresponding mesh will have NC2 resistances, means n into n minus 1 by 2 resistances the corresponding mesh will have. Suppose if this n is a 3 into 3 minus 2 by 2, which is 3. Hence, in star also it is 3 resistances, in delta also 3 resistances. If it is 5, this n is 5, then this will be 5 into 4 by 2, which is 10 resistances. In the corresponding mesh, it is 10 resistances. Okay. So when you look at this star mesh, don't get confused. What is this mesh or node? No, it's not mesh or node point. It is a star mesh transformation, which is a basic transformation, which is the most generalized transformation, for the star delta. Okay. I hope it is clear. So the answer for this is option B. I'm going to the next question. Bring it on. Next question is on the screen. Go for it. So meanwhile, I'll take up the questions from the chat. Okay. This is one of the beautiful piece of questions. Surendra is saying, sir, I have a personal question regarding gate. PEలో ఎంటెక్ చేస్తే ఐఐటీస్లో గుడ్ ప్లేస్మెంట్ వస్తుందా లేదా నేను ఈసీ పేపర్కి VLSIకి వెళ్ళాలా కన్ఫ్యూజన్ బిట్వీన్ విచ్ పేపర్ ఐ చూస్ ఫర్ 2025. Surendra, you WhatsApp us in the given number. Okay, I'll try to call you personally, guide you personally. That's much better. Okay. If you are good enough, Surendra, if you are good enough, if you are conceptually good enough, job offers are there. We'll take care of it. That's what I'm saying. You follow the WhatsApp channel. For you people, electrical, electronic instrumentation people, we are tying up with different institutes. Okay. We will train you. We are tying up with MathWorks, we are tying up with Orangeworks, we are tying up with some VLSA companies. Okay, so we'll be training you guys for those positions, and they will take you, if you are qualified enough, they will take you directly. Shortly, we're going to announce that as well, very shortly. So stay tuned. All these announcements will be happening in the WhatsApp channel. So follow that WhatsApp channel. Anyways, I think you're done with this. So people are saying option B is answer. Good. To WhatsApp, you don't have to save the number and all. In the description, link is a WhatsApp link. Just click on that. It will come automatically. Okay. And shortly, we have a couple of interesting things to share. Okay. We are building our own artificial intelligence GPT, like Chat GPT. Okay. So we are training, that's what I said a couple of months back. We are training the GPTs. So that is over. Okay. Language models, we are trained it. Shortly, we are going to give it to the public also, I mean to you as well, so that we can make advantage of this. So yeah, anyways, time's up. Let me just try answering this. Calculate I naught for the circuit diagram given below. For this circuit, you'll have to find out this current. Okay. Don't worry when you're handling these kind of uncommon questions. Okay. What you have to do is you have to apply your basic concepts. First of all, I'll have to find out this current. Okay. So these two are in shunt, right? These two are in shunt. Resultant is how much? 1 ohm. These two are in shunt. What is the resultant? 6 by 3, 2 times more, 6 by 3, which is 2 ohms. So this voltage will be, voltage across this will be 10 volts, voltage across this will be 20 volts. Simply by applying voltage division, I'm not even applying voltage division, the ratio. Voltages are proportional to the resistance. This is 1 ohm, this is 2 ohm. So this voltage, when this voltage will be double that of this voltage. So with a common sense, I can say, with your regular aptitude skills, I can say this is 10 volts and 20 volts. Or if you don't have that, practice, with the practice, you will get all of these. If you don't have that practice, you can simply apply voltage division rule, which are clearly described in our courses, even the free lectures also. Okay. So this is 10 volts. If this is 10 volts, the voltage across this is 10 volts. What is the current in this? Current in this is 5 ampere. Okay, this current is 5 ampere. Now what is this current here? This voltage is 20 volts. This voltage is 20 volts. So this current is 20 by 3, which is 6.66. Okay, which is 6.66. This is 5, this is 6.66. So this current must be 1.66. This current must be 1.66, then only this can be 6.66. So definitely answer is a negative, not positive, because I naught is given this way, current is flowing this way. So A is wrong, C is wrong. 10 by 3 is 3.33. 10 by 3 is 3.33. Are we right? Yes. Now it is 1.66. So 5 by 3 is 1.666. Negative, current is opposite. So answer is B. So whoever answered answer B, you guys are amazing. Good, Viraya. Viraya is back. Viraya is back. Walter Viraya is back. I'm back to the next question. Try to answer this ASAP. Yes, go on. So generally, for Surendra, are you there? Surendra, are you there? Surendra, smiley. I recommend for electrical people, I recommend you to appear both electrical and electronics, or maybe electrical instrumentation. So I recommend you to appear 2 papers. Okay, either or, it's not that you have to appear both. That's what the best advice. Five seconds. Oh no, what happened? Such an easy piece of question, yet we got less responses. How come? How come? For this question, it's too bad, terribly bad. Anyways, what's the question? I discussed already this right at the beginning. When the total charge in a capacitor is doubled, the energy stored. See, energy stored formula is energy stored is equal to half of CV square. It is said total charge in the capacitor is doubled. Okay, this got doubled. Now the relation what we have is C and V. We don't have a relation for energy and Q, but you can make it out. You know Q is equal to C into V. So we can say CV square as CV into V. C into V is Q. Half Q into V is the energy stored in the capacitor. So energy stored and Q is proportional. If Q is double, energy stored in the capacitor will also get double. Simple. Simple point. I don't know why you guys have missed it. That's not expected. That's not expected. Shall we go to the next one? Okay, this is AP SPDCL question. This is a transco question. Give it in the comment. When you're watching recording also, you can give it in the comment for question number 10. Right now you're at the question number 10. Okay, you can see the question numbers over there, right? Yeah. Nice. We got pretty impressive answers. Good, guys. Very good. $15 seconds more. Time's up. Simple question here. The voltage waveform V of t is equal to 12 t square is applied across 1 Henry. 1 Henry inductor, the voltage applied is 12 t square for t greater than 0. With the initial current through it is 0, the current through the inductor, this current is how much? We know V is equal to L di by dt. L is anyways 1, it's gone. V is equal to di by dt. Now you want I is equal to integral I dt, simple. Sorry, integral V dt, simple. Voltage is 12 t square, simply integrate it. That's it. At least now the answer. Yeah, somebody has given the discussion also. I mean, he elaborated. Kranti Kumar. Yes, you're absolutely right, dear. Okay, good. With that logic, answer is simply integration of this. You'll get 4t cube. That's it. Okay. Let's go to the next question. This is ISRO question. Simple one, but very important one. ఇస్రోలో అడిగినటువంటి క్వశ్చన్ చూడండి, సింపుల్ క్వశ్చన్, కాన్సెప్చువల్ క్వశ్చన్. ఈ పాయింట్ చాలా యూజ్ అవుతుంది పవర్ సిస్టమ్స్లో. ఓకే, లిమిటేషన్స్ ఆఫ్ దిస్ కీచ్ లా, కిర్చాఫ్స్ లా. Good man, you are amazing. Most of you are right, but others are not responding. I don't know what happened to you all. Let's check it out. I think 1 minute is waste of time for this. Kirchhoff's law fails in case of linear, non-linear. It will work. It will work. Both voltage law, current law, both will work for linear as well as non-linear. Dual network. What is a dual network? I think KVL and mesh and node, when they are happening, it's a dual network. Yes, it is pretty much valid. For distributed, nah. It fails. You cannot use these for distributed networks. Only for lumped networks you can use. Resistance means resistance. Lumped as a separate thing should be there. That's why we fail to, or we'll go when we're analyzing power systems, long transmission lines. You are considering the network parameters to be distributed, so you cannot use KVL, KCL. There you will use a different analysis. You will take only infinitely small transmission line. From there, you'll just extend it with integration and all, because you cannot use KVL, KCL for the distributed networks. Okay, this is a basic thing, but it is one of the questions asked in ISROs. Yeah, this one is also ISRO one. Try this out, buddy. Try this out. Yeah, what is it? What is it? Monica, Vamshi, come on, Veeraya has answered it already. Let's check it out whether it is right or wrong. Kranti Kumar, Veeraya, can you check your answer once again? Chandu, can you check your answer once again? Vamshi, can you check your answer once again? Simple question, yaar. What's going on? Anyways, 10 seconds. It's not really that a big question to take 1 minute of time. In 4-branch parallel circuit, concept of parallel circuit, you have a circuit, 4-branch parallel circuit, flowing in each branch is 50 milliampere in each branch. All are in 4 parallel paths. Now if one branch opens, means this voltage, there is a fixed voltage here. One branch is opened, then the current in the other branches, why current in the other branches will change. As long as voltage is fixed, these will be same. They will not have any effect. They will be unaffected. That is why at your home you will be using parallel connection. Me intulo lights అన్ని ఫ్యాన్స్ లైట్స్ ఇవన్నీ ఎలా ఉంటాయి, ప్యారలల్లో ఉంటాయి, సిరీస్లో ఉంటాయి, అన్నీ ప్యారలల్లో ఉంటాయి. ఎందుకు? ఒకటి ఖరాబ్ అయినా కానీ అది తీసేసినా కానీ మిగిలిన ఎఫెక్ట్ ఏమీ ఓపెన్ అయితే, షార్ట్ అయితే మిగిలిన ఎఫెక్ట్ అవుతుంది, వేరే విషయం. ఓపెన్ అయితే నో ఎఫెక్ట్. అదే దివాళీకి సీరియల్ దండలు అంటారు కదా, అందులో ఒక బల్బు పోయినా, అవన్నీ సీరియల్ అంటే సిరీస్లో ఉంటాయి అన్నీ, ఒక బల్బు పోయినా మొత్తం పోతాయి. ఓకే, ఆర్ ఈరోజు రేపు ఎల్ఈడి ట్యూబ్ లైట్లు వస్తున్నాయి కదా, స్ట్రిప్ ట్యూబ్ లైట్లు, అందులో కూడా మధ్యలో ఒక లైట్ పోయినా ఆ స్ట్రిప్ పోర్షన్ అంతా పోయినట్టే, బికాస్ దే ఆర్ ఇన్ సిరీస్. ఓకే, సో దే డోంట్ హ్యావ్ ఎనీ ఎఫెక్ట్, దే ఆర్ అన్ఎఫెక్టెడ్. నైస్ క్వశ్చన్. మీ ఇంట్లో ఉన్న కనెక్షన్ ప్యారలల్ కనెక్షన్, సిరీస్ కనెక్షన్, ప్యారలల్ కనెక్షన్, ఎందుకు ప్యారలల్ వాడుతున్నారు, ఎందుకు సిరీస్ వాడట్లేదు, ఇవన్నీ లాజిక్స్ వస్తాయి అనమాట. ఓకే, yes, you're right. Kranti Kumar has well explained this point. Overall current, ఈ overall current అనేది ఎఫెక్ట్ అవుతుంది. Yes, there will be a reduction in this, but it is asked for current in the other branches. Individual current branches will have no effect. He is absolutely right. Okay, let's get to the next question, which is also ISRO. वाह, क्या बात है. I think దీనికి టైమర్ కూడా వేస్ట్. ఓకే, let's see. Two number of 500 ohms, 1 watt, 500 ohm, 1 watt. ఓకే, రెసిస్టర్స్ రెండు ఉన్నాయి, ఆ రెండిటిని ప్యారలల్లో కనెక్ట్ చేసి ఉన్నారు. సో ద మూమెంట్ దే ఆర్ ఇన్ ప్యారలల్, డెఫినెట్లీ పవర్ ఆర్ ఓమిక్ వాల్యూ ఈజ్ నాట్ దిస్. టోటల్ రిజల్టెంట్ ఓమిక్ వాల్యూ ఇస్ 500 ప్యారలల్, ఇట్ ఈస్ 250. మరి పవర్ ఏమవుతుంది సార్? పవర్ కూడా హాఫ్ అవుతుందా? హాఫ్ వదరా బాయ్. మీ ఇంట్లో రెండు బల్బులు ఉన్నాయి, రెండు ప్యారల్లో కనెక్ట్ అయి ఉన్నాయి. ఒక బల్బు 1 వాట్ బల్బు, రెండో బల్బు 2 వాట్స్ బల్బు, రెండు కనెక్ట్ అయినప్పుడు టోటల్ పవర్ ఎంత? 2 వాట్స్ అవుతుంది రా బాయ్. పవర్ యాడెడ్ అప్. ఓకే, సో దీని పవర్ రెండింటి పవర్ కలిపి టోటల్ పవర్ కన్స్యూమ్ అవుతుంది 2 వాట్స్. సో 250 ఓమ్, 2 వాట్ is the answer. B is the answer. Most of you, not most of you, every one of you answered correct. Good. Next question. Next question here. If you have learned something, if you want to continue to learn something, follow our WhatsApp channel. Description is already in the description or in the chat. It is given in the comment, it is given. What I'm saying is only for WhatsApp following users, we are going to announce something amazing for EEE, ECE people, instrumentation people, job offers, BTech and MTech. So take it to that your advantage. Your time is up. Copper behaves as, we know copper is one of the good conductors. Can you tell me what is the metal which is having highest conductivity? The metal with the highest conductivity, what is that metal name? Can you name a metal with highest conductivity? What is that? Yes, give it up in the chat. No, not gold. Yes, Mohammed, you're right. Yes, Chandu, you're right. It is silver. Silver is the highest conductivity material. Now, when it comes to usage, what is the best conductor in use? What is the best conductor in use? Copper. Why not silver? Price is an issue. Okay, so with respect to other issues, we're not using silver, we're using copper. Even aluminum is having a lower conductivity compared to copper, still we prefer aluminum. Why? Paisa. Come, less price for aluminum. Anyways, everyone knows it is a good conductor. Now copper, will it behave just as a conductor, or can it give dielectric? Can it offer dielectric strength? To that, answer is no. It is just a conductor. Because it is having highest conductivity, it cannot offer good dielectric property. Just copper piece, if you take, if you want to, you can use the copper as a plate for the capacitor, but not as a dielectric for the capacitor. Okay, so it will not work. It will anyways follow the current, allow the current. Okay, so it behaves as a conductor always. Okay, so to end the session, let me give one of the popular questions which I think everybody will be answering it. So you try to answer this question in the comment. Okay, you try to answer this question and give the answer for the question. Question number is, I think question number is 15. For 15th question, answer it in the comment. Okay, so 15 questions of today's session is over. We'll also have a 1 hour session. Okay, I'll definitely meet you with some more interesting questions in the next tomorrow's session. Next session means not too long session. Just tomorrow we'll be having another session with some other interesting questions. We'll be learning some concepts through those interesting questions. Okay, that's it of this lecture, guys. Thank you for joining me. Have a good time. Bye bye. ठीक है भाई, बंद कर दो.